This session is the session on the Qalb shared task. As you know, there was an associated shared task with the workshop, which had to do with text correction. My colleague here, Ella Rozovskaya, and I will present the talk about the shared task to tell you about it and summarize the results. And then after that, we will have quick 1-minute presentations that are kind of teaser style presentations by the people who participated in the shared task who are able to be here. And then we will have a small panel. And so all the people who are on the shared task, please maybe come over here. Well, I don't know how we're going to do it. We'll bring a chair with you. We'll sit there. We'll talk. And Huda, you'll be keeping track of time for us all. After that, there will be a short 1-minute presentation also by the poster presenters. The whole idea of a teaser presentation, for those who have not done it, is just to be like an advertisement, so that you see there's 17 different posters. You want people to come and talk to you and know about what you're doing. Okay, so I'm going to start. I'm going to do the first half of the presentation, and then Ella will talk on the second half. This is work that was organized by a group of people in Carnegie Mellon, Qatar, and Colombia, and me, Behran Muhit, Allah who you met, Wajdi Zaghwani, and Osama Abeid. And Behran unfortunately could not be here today. So the background of the shared task is automatic correction of text. And automatic correction is a very interesting application because it at once has its own direct target functionality, meaning people will want to use it as an application itself. People want their text to be corrected when they're typing, let's say, and they wanted their spell checked and grammar checked. At the same time, as technologists, it has this enabling technology quality where you could use it, even with some mistakes in it, as a way of pre-processing data to get rid of noise in the data to improve, lower the sparsity in the models that you're developing. So there's a long history of working on this problem in English, and there have been very specific shared tasks, particularly the famous ones are in Connell in the last couple of years that worked on this problem for English. And those were actually English written by non-native speakers of English. Now, in the case of Arabic, the history of work on this is relatively shorter and the amount of work is smaller than happened in English. I list here a few efforts, and I'm sure there's more, but notice, and I'm not going to go through them for time, but there's a lot of work that was done by people who were actually in linguistics looking at phenomena that have to do with non-native speakers and what kind of mistakes they make. People looked at manual annotation of error types as well as correction, and we find corpora that range from like 9,000 words, which is quite small from our perspective, to 280,000 words or so. And then there's the Qalb corpus, which I'm going to talk about today a bit more, which is 2 million words. And as far as we know, this is the largest collection of manually corrected text for the phenomena of spelling error and grammar error. And of course, the Qalb corpus is the base for the Qalb shared task to do the automatic correction on Arabic text. So as far as I know, this is, please, some of the older guys here can tell me if I'm wrong on this. Knowledge, as far as we know, this is the first forum in which we actually do a shared task where we get people from different groups to compete in the task of doing spelling correction. We were inspired by similar shared tasks like the NIST machine translation evaluation and also the Connell evaluations. We followed very similar format to them. We created a bunch of resources. We gave them to all of the participants. There was a timeline. Everybody got development data to compete with, and then they also got a test set and a period of time to do to run their system on the test set. They return it to us. We evaluate using a common standard. We actually used the same scoring methodology that's used in the Connell shared task. And we followed their guides kind of in a lot of our decisions to benefit from their experience. Now, a few words about the Qalb corpus. Qalb stands for Qatar Arabic Language Bank. It's funded by the Qatar National Research Fund. It's a collaboration between Columbia University and Carnegie Mellon, Qatar. And the idea was to create about 2 million words of text manually corrected. They include news, commentaries, native and non-native essays, and also machine translation output. The work that we did here for the shared task was specifically from the news commentaries. The annotation for Qalb used initially meta to help us resolve some of the very basic spelling errors that are common in our data. This is the ta marbuta spelling and the alif and ya spelling. So alif hamzation is very commonly misspelled in Arabic, in standard Arabic. I should also add, actually, all of the work that's done in Qalb is standard Arabic. There is no dialectness whatsoever. Anything that was deemed to be too dialectal was thrown out. However, we did allow words, comments that may have had dialectal clitics, but if the base word seemed reasonably like a standard Arabic lexical item, we would allow it. So if somebody said biktub, we count that as acceptable, but we correct it by deleting the ba and just say yaktub in that case. So we do effectively de-dialectization on things that are, more formal, I suppose. People were given guidelines and trained on them to do correction for spelling, morphology, word choice, syntax, and dialectal usage. And in terms of the system itself, this will get translated into core things like edits, adds, mergers, etc. We did not annotate for error type. We thought that was actually too complicated to have annotators do, and we wanted to get more data with correction rather than getting a smaller set with error types associated with it. We developed a tool as part of this work called Qawi, which stands for Qalb Annotation Web Interface. And this was developed in Carnegie Mellon, Qatar, and it's the tool that we use to do all of the annotation work on. This example is the one that I show in the paper, so you see what the original looks like and what the corrected versions look like. And you read this and you'll say, well, this looks decent. It's not something that is shockingly wrong, weird errors. But when you look very carefully as Arabic speakers, you will notice all the things that they're doing that are not very consistent, in spelling the hamzas, etc. So I'll pick a couple of examples here. Number one below, spelling, words like meta, for example, with the two dots instead of the alif maksura. So we correct for such thing. Putting the correct hamza is something we do. We also controversially decided to do punctuation correction or punctuation insertion. And in news commentaries, people notoriously just it's just like allergic to using punctuation. So this was very hard, and it was one of the things we had a hard time getting a high inter-annotator agreement on, but we thought we still should do it as part of the task. I was inspired by this by thinking of this is something, if I was an editor in a journal and I'm actually doing this, I would make sure to put all the punctuation in the right place. So we wanted to get information to help us with that. More obvious things at the bottom, like bi'ul or biqul becomes yaqul, or yuhaqqiquha al-an, or li'anna, it's put as a single word and you want to separate these. So all of this is handled or annotated for in the data. Now, as I said earlier, this is news commentary. It came from Al Jazeera, actually, and we thank Al Jazeera because they contributed the data for us and they allow us to make it publicly available. So the corpus is actually public. You just have to register that you got it and you cite appropriately and always say that, where you got it from. As I said, also, it's modern standard Arabic. The documents are really comments, the terminology we're using here, and they tend to be about 40 to 60 words. We dropped things that were too short and things that were too long and just focused on this range. And then the splits in training, development, and test was done based on time. So when we actually started the evaluation, the test set that was used was not annotated yet. It got annotated in the earlier period, and it was something that we have not even seen when we gave the training data. The data was provided in the raw, together with the corrections and the sequence of correction items that say, edit this word, or, merge this, insert, etc. And it was pre-processed and by adding Metamira features. And I'll go through this very quickly. The training data was 1 million words, and the development and test were both about 50,000 words. We think this is a very nice data set. It's quite comparable to the data sets that are used in English for CONAL evaluation. The number of errors are about 306,000. It's like, 30% of the words had some kind of a bug. You can bet a lot of them are things like the dotting of the alif, hamza, but there's also other things going on too. All of the data was processed with Medamira, which I mentioned, I think, earlier. This is a new version that combines Meda and Amira, and it's publicly available now. And here we're using it in the standard Arabic mode, not in the Egyptian Arabic mode, of course. The features that we included were things like person, aspect, voice, mood, gender, different part-of-speech tag forms, telling what the words are, they're cliticized or not. This is important. We're treating word here as white space separated or punctuation separated. So things with clitics like, وَسَيَكْتُبُونَهُ is one single word as far as we're concerned. It's not multiple words. And this is how Arabic is written, and this is how you correct it, basically. You want to keep that. We also included the fully diacritized form of the word, which includes the alif ya ta marbuta correction. When I say correction, it's not guaranteed, obviously. This is what the prediction is from Medamira. And then the undiacritized form. The last one is an important feature that we provide because in many cases, this is actually includes in it the correction of alif, ya, and ta marbuta. So a very simple baseline would have been to just take that feature and put it in the output and claim to be that is actually your answer. In terms of the distribution of the error types, we got about 55% were edits and about 32% were ads. There's actually a missing point here that I wanted to put. The inter-annotated agreement that we got for the work was actually closer to 98% within a measure that we use for average accuracy agreement between the different annotators. And that's when you look at the words without punctuation. If you include all of the punctuation decision, the number drops to about 93%. So a very large percentage of the errors that we're getting is from punctuation. And Ella, who's going to talk about the error analysis, will actually bring this issue up again. I think, Ella, it's your turn.
Okay, hi. So we are going to continue with participants and approaches. We were lucky that there was a lot of interest in the shared task. We had 9 participating teams, and actually this is on a par with the Cornell shared task this year in English error correction. We got 2 teams from the United States, Columbia University and George Washington University, 2 teams from Qatar, Carnegie Mellon University Qatar and the Qatar Computing Research Institute, 2 teams from Cairo, 2 teams from France and a team from Algeria and Tabuk University. We allowed up to 3 different outputs from each participant, and overall we received 18 submissions. And it was very interesting to see that people used a very diverse set of approaches. These included statistical machine translation systems, rule-based approaches, and machine learning systems. Also, if we look at the teams that scored at the top, they also employed very different approaches, and they actually used different components and combined them within their systems. For example, the Columbia University used machine learning rules and Medamira corrections. As Nizar mentioned earlier, one of the features that Medamira produces is a suggested correction for words that have aleph and ya problems. The CUFE team extracted rules using the output of morphological analyzer, and the CMUQ team used statistical machine translation rules and also Medamira corrections. Now, almost all of the systems, with the exception of one team, used the annotated Qalb training data that we provided. The data was used for training SMT systems, machine learning systems, and also for developing rules. In addition, several teams used Medamira features, including the Medamira corrections for aleph-ya errors. And also we encourage teams to use any other different resources they wished, as long as these resources were publicly available. So the top 2 resources that people used were the Error Complex Dictionary and the Arabic Gigaword Corpus. And if you look in the shared task overview paper, we list all the resources for each system, and you can also look at the specific task description papers. So now let's move on to the results of the competition. Before we look at the performance numbers, I want to say a few words about evaluation. As Nizar mentioned earlier, we followed the guidelines of the Conal shared task and the WHO shared task on English error correction. In accordance with this, the standard evaluation measure that we used was the F1 score and also the precision and recall. And to score the outputs of the systems, we used the official Conal shared task max match scorer. The max match scorer produces F1 and precision and recall. It is important to note here that the F1 score does not reflect the accuracy of the text. So we don't know how many errors remain in the text after running, as a result of running someone's system. But if you are more interested in this, we can talk about this in more detail later. So here we show the official results on the test set. As I mentioned, the official scoring, the official metric of the Qalb shared task is the F1 score, showed in the third column. The first column shows the rank of the system, where the rank is determined by the F1 score of the system obtained on the test. Since people were allowed to submit up to 3 outputs for each team, we selected the output that produced the highest score, and we show it here. We were very pleased to see that the teams actually did very well on the task. And even though the range of the scores was between 30 to 67 points, most of the people stayed in the 50-60 range. And you can also see the precision recall numbers that correspond to these F1 scores in the last 2 columns. Even though the rank was determined by F1 and the systems were optimized on the F1 score, we also wanted to know what the precision and recall numbers are. So in addition to these results, we also requested that the participants submit their performance on the development test, their output on the development test. And these results should not be interpreted as official scores, but the reason we wanted this was to see if there was a discrepancy between the performances on the development and the test, and if there was a big difference in the rankings of the systems obtained on the test and the development. So one thing that we saw was that actually the performance on the development and the test was very similar for most of the systems, and actually the performance on the test was slightly higher, which may suggest that the test data was a little bit easier than the development data. We also noticed, if you look at the first 2 columns, we see the rank of the system according to the test and development results, respectively. We saw that most of the teams did not change their rankings, with 2 exceptions. The first one is the first 2 teams, they actually swapped places, the CLMB and the CUFE teams. The CUFE teams obtained the best result on the development. The second exception is the CP13 team, which had a much better ranking on the development test, but then dropped on the test. Okay. Finally, we wanted also to look at the performance by error type. As Nizar mentioned, the Qalb corpus is not annotated with respect to error types in the linguistic sense, but is annotated using the actions that are required to perform to produce correct output. However, automatically we can isolate certain groups of mistakes, and we thought it made sense to look at 2 groups of errors specifically. One of them is punctuation mistakes. As Nizar mentioned, over 30% of errors in the Qalb corpus were punctuation errors. And one can argue that punctuation mistakes require different types of processing compared to the spelling or grammatical errors. So we decided what would happen. We wanted to see what would happen if we ignore punctuation errors and only evaluate on the other mistakes. So in the second column, you see these results, and here actually we see that the best performance is obtained by the CUFE system, which in the official scoring placed second. Another interesting thing to note here is that without punctuation errors, the results actually go up, which may suggest that punctuation mistakes are easier than other mistakes, or maybe people tried to focus on other errors. In the next column, we see results when Aleph-Ya errors are removed. Now again, this is a special group of errors. Some of them are handled by Medamira, and they're very common. So what we see here actually is that compared to the official ranking, when we remove the Aleph-Ya errors, performance drops significantly. Again, this might suggest that the Aleph-Ya errors are actually easier than other types of spelling or grammatical errors. So if you ignore them, then it's more difficult to get a good result. And finally, in the last column, we show results when both punctuation and Aleph-Ya errors are removed. Here again, we see that the CUFE team actually obtains the best score. So now we are going to move to the last part, which is analysis. So we wanted to know what did we learn from this task, and one thing is, which is also going to be discussed at the panel, is what presented most challenges to the shared task participants. And one way to look at this was to rank all the test sentences by the averaged F1 scores over all the 18 submissions, and then we selected 50 sentences that had the highest F1 scores and 50 that had the lowest scores. So we assumed that the lowest scores corresponded to the most challenging sentences and the highest F1 scores corresponded to the easier sentences. So then we tried to analyze the errors in both of these groups. We saw that the most challenging sentences contained more errors, and the errors were more complex and required multiple changes to be made. The easiest were those that had fewer errors, and also the errors that involved the Aleph-Ya phenomena. And if you recall actually from the results that I showed, when Aleph-Ya errors are removed, then the system's performance drops, which actually supports this claim that the Aleph-Ya errors are easier than other mistakes. Finally, we also produced 2 experimental systems using the outputs of all the teams. The first one was the Oracle upper bound estimate. The idea was here to see if the systems made different mistakes on the data, or if they were complementary to each other, or they pretty much produced the same output. And in this table, you see in the first row, you see this Oracle result. And compared to the best system, the CLMB, in the last row, we see that if we use the Oracle system, then we get an improvement from 67 to 75, which actually indicates that the systems are complementary and they produce different outputs. Now, since they are complementary, another experiment that we could do is use the majority voting, which is shown in the second row of this table, where we select the output that majority systems produce, or if there is no majority, then we default to the CLMB. And here we see, unfortunately, that there is no improvement compared to the best system. And actually, it turns out that the reason is that the outputs are so different that the systems, in most of the cases, do not agree with each other. So in over 90% of the cases, we have to back up to the CLMB system. So that's why there is no difference. So to conclude, we presented results on the first shared task on Arabic error correction. The shared task attracted a lot of interest in the NLP community, resulting in 18 submissions from 9 teams. We presented the results of the competition, and I think we learned a lot from it, and we can discuss it further at the panel. The shared task data and the outputs of the participating teams will be made publicly available for research purposes. And finally, what is next? We are organizing another shared task next year. And in addition to the native data that was used this year, we'll also use non-native data, so it will be an extended and improved competition. So, thank you.
So perhaps questions for us first, and before we start the 1-minute teasers.
Actually, I have one question about rubber combination. How do you apply this combination? Just all of the system together, or just a part of system? Because it's not, if we have, for example, 9 systems, and we combine all of them, maybe we lose because one of them select the wrong answer, so the vote combination is not.
Are you asking about majority vote?
Yeah.
So for majority vote, we looked at each sentence separately and used the output of all 18 submissions, yes. And we used the output that had the majority votes, or if there was no majority, then we defaulted to CLMB system.
Yeah, the majority vote it was kind of a baseline idea. Remember, these comments are 40 to 60 words. So to have a majority, to have an agreement, it means you have to agree on the 40 to 60 words, which is extremely unlikely. You know, and the few times that it happened, it actually, I mean, sometimes it helped in terms of precision, but it hurt in terms of recall. So as a very dumb, simple idea, I mean, we should have known it wouldn't go anywhere. The oracle, I think, is more indicative of the potential of doing system combination.
The majority voting, when we use just the 5, for example, it doesn't have,
because they don't agree. I think what needs to be done is that you look at the agreement so that you build a confusion like this, and then you do it on the segment level.
That's right.
Then you get a vote.
That's right. And I think that's kind of the direction that we would have to go into, doing a smarter combination of using parts of the lattice where they agree to kind of boost and others not. Yeah.
it's without confidence.
No, no. This is, remember, this is not a presentation about doing system combination. This is actually a presentation about the share task with a pointer to motivate future work. If you're interested, the data is available. We would love, so you got it. Yes, we want to do more work in the direction of system combination. That 75 number looks very attractive to try to get to. Usually deceptive oracles get you in trouble more than that. Any more questions? Yeah.
Can I get a hint like how to use Rebel's website, how to download it, or if you want to contribute in the future, how to do this?
Yes, talk to me and Allah after and during the break. I can tell you all you need to know. Yeah.
I have a question regarding the gold standard. Did you measure inter-annotator agreement for producing the gold standard?
Yes, we did. And I am, as I said when I presented, I made a version of the slide with the number. I'm happy to send it to you. It's actually already published in LREC this year. There's a paper, Zaghwani et al., 2014 in LREC, which has a whole section at the end just about the inter-corrector, inter-annotator agreement. And we present two set of numbers there, one based on the average word error rate, and another one based on, I think it's called average pairwise percent agreement. And the average agreement was 93% if you look on everything, and 98% if you drop the punctuation. So punctuation is a big cause of problems. And I think in terms of the average word error rate, the number was like 11.3 word error rate if you include everything, and I think it was 4 or 3.8 if you just look at things without punctuation. So the numbers are there. We followed very strict guidelines of getting the annotators to train. Unfortunately, punctuation is just very elusive, and there were lots of disagreement among them.
So the results are very high, which is good. Especially I'm surprised for the punctuation, because maybe we'll discuss it later on during the panel, but there is no clear real rule, grammatical rule to do punctuation, especially for weak punctuation performance.
Yeah.
So I'm surprised that
There's also, I mean, there's also from our experience with the annotators a lot of ignorance or lack of understanding of what the rules of punctuation in Arabic is, particularly the use of the comma. So some of our annotators applied the rules of comma that they learned, which were English comma, and those are actually quite different from the rules of commas in Arabic. And the rules of commas in Arabic seems to be just unintuitive to some people. So yes, I agree. I mean, perhaps more work needs to be done in that area, and it could be an interesting thing to work on, for sure. Yeah, we have to stop, and then Wajdi, you're going to be the master of... okay, here you go.
Okay, so I invite first the talk with for Arabic spelling correction using supervised learning by Yusuf Hassan. So, okay,
guys who know you're going to be up, you can actually line up. Because it's going to be like
1 minute, yeah.
Hello. In this work, we are targeting to fix the errors. We are targeting 4 types of errors. The first error is the edit error, where a word is transformed using 1 or 2 transformations of the word by removal or addition or transformation or transposition of the word in the sentence. The other type is the add before, which is mostly the punctuation error, removal of punctuation. The third one was, the third and fourth are the merge and splits, which is the addition or removal of a space from the word. That's it. By combining those 4 error correction methods, we get the 6th place in the shared task. That's it. Okay, thank you.
So the next is autocorrection of Arabic common errors for large text corpus with Taha Zarruqi.
Hello, I am Taha Zarruqi. I am a developer of open source programs about Arabic NLP. I work we have Ghalatawi. Ghalatawi is just a program to just correct some error with accurate, but it can't correct all errors. Donc if we have إذا with Hamza below, and we have a lot of programs like this Mishkal. Mishkal is Arabic text vocalizer, and Qotrob for verb conjugation, and ISPEL. I work on ISPEL as a spell checker for Arabic, and then I have a lot of experience on correction, spelling checking, and autocorrection. This is spell checker, but the Ghalatawi is autocorrection for exactly some words with alif and ya phenomena, and some words with that and the errors. Okay, thank you.
So our next is automatic correction of Arabic text, cascaded approach with Hamdi Mubarak. Please.
Hello, good morning, everybody. This is our approach in correcting Arabic mistakes in Arabic text. We used large corpora generated from Al-Jazeera.net, 10 years span of Al-Jazeera.net, in addition to all the Arabic Wikipedia, and errors in these 2 resources are infrequent. And we applied 2 models to correct spelling mistakes and 2 models to correct punctuation errors. For error correction, we created a model for character level model. We aligned words at the character level with the errors and their correction, and uses Giza++ Moses to align these pairs, and also use a case-specific model to correct specific cases in error like Hamza error, Ya error, split or merge errors. And for punctuation recovery, we tried 2 models. CRF model that is generated from the parallel data trend from Qalb data, and simple statistics model by extracting the n-grams that are followed by or preceded by certain punctuation marks with certain thresholds. We applied system combination for these different models, and the best results was obtained from cascading character level model followed by the case-specific model. And when we try to add punctuation recovery model, either before or after, we didn't achieve any progress. Thank you.
I ask Huda to come for the Qalb CMUQ at Qalb 2014 SMT-based system for automatic Arabic correction. Okay, please, yeah.
Hi everyone. Today we will present our system that we built to participate in the Qalb share task. So if you want to know how to use machine translation to automatically correct spelling error for Arabic, and how to build an automatic corrector using the Qalb corpus, and especially if you want to know how we got the 3rd rank, come and see our poster.
Thank you. That was quick. So the next is Fast and Robust Arabic Error Correction System by Michael Nawar. So just,
Okay. In this work, we have proposed a probabilistic rule-based system. We have designed the system to satisfy 2 main criteria. The first one, it is designed to maximize the F-score by applying some kind of acceptance rejection technique. Second, it is designed to be really fast by generating the minimum number of alternative of a corrected word, so it will be fast since we are working on a PC or something like that. Achieved 0.68 on development set and 65 on test set. Thank you.
So the next system is the George Washington University Hybrid Arabic Spelling and Punctuation Correction. And I'm not sure who will be presenting. I think Hiba? Yeah, please, yeah.
Hi everyone, I'm Hiba Fardi and I'll be presenting the George Washington University system on behalf of my colleagues. So our system uses modular, like it depends on several modules, so it treats every type of error differently, so punctuation versus word versus non-word errors. So it depends on classification, uses machine translation, and also checks a bunch of rules and word lists. It ranked 5th in the task. Oops. It got the 5th rank among the participating systems, so if you're interested to know more about it, please come to my poster. Thank you.
So our next system is the Taqlimat system description for the shared task on Arabic error correction by Jamal Mustafa. So he's not here.
So I can say a few words about our approach.
Okay.
So Taqlimat is a French company. It's a startup, a spin-off of a French CNRS, and we have been building Arabic language processing tools. So basically, this is our first attempt to deal with spell checking in Arabic. And for this purpose, we found that this evaluation campaign would be the right place to test and to start working on that. So we have implemented 2 systems. The first one is a rule-based system based on unspell and ispell, and we try to modify the lexicon and the affix rules files. And the second system that we built was a statistical machine translation system, and we saw that the results, the best results were obtained with the machine translation system with a F-score of 60%. And I welcome you to see more information on the poster, and I would like to thank the organizer because they provided us with a very good corpus that enabled us to develop a system very quickly in 1 week or so. So I really wanted to thank the organizer for providing the corpus, and I look forward to participating to the next evaluation campaign next year.
So the last system in this session is the Columbia system in the Qalb 2014 shared task on Arabic error correction, and I invite Ala to come. Okay, please.
Hi, so I'm going to present the Columbia system that we built together at Columbia. So our system ranked first, and it includes several modules for addressing different types of mistakes, punctuation errors, spelling errors, grammar errors, dialectal usage, and other things. The components are also diverse. We have machine learning modules and rule-based components. Just to take a look at some of what we did, we have a maximum likelihood estimator, naive Bayes model for unseen words, generalized spelling error correction model, and pattern-based corrector. And to learn more about it and why we placed first, please come and see our poster. Thank you.
Thank you. So now we will have our panel. So we would like to applaud everyone. Yes. So we will have a group discussion.
Yeah, thank you, HD. I actually prepared a few questions. I imagined that we would have a bunch of chairs here for the people who would be on the panel, but this may not work. So we just pretend we're all in the panel. How's that? And we can? Sure, go ahead. Yeah, I mean, it's... Yeah. Come on, Ella, let's start. Yeah. There you go. Yeah. Okay. Okay. Now, of course, the questions for the panel are hidden behind the chairs. There's no way to do this. Okay. So I put up some questions just in case people will not have anything to say, which I will very much doubt. Please come in. And I'm just gonna. What's that? Are you? Yes, please. Yeah, maybe. Actually, that's a good idea. Just hide it. Yeah. Yeah, just turn it off. So, Michael, you can, So thank you all. I mean, this could not have happened without all of your hard work and participation. So I'm just going to start by saying a few questions, and then I'll let you, fight over what you want to say. Or so maybe think about the experience, what worked, what did not work for you, whether you think there were surprises or particular challenges that you did not expect, any insights that you got from looking at the data. So let's start with that set of questions.
So your question is, did we face any challenge?
Yeah.
In this corpus?
Yeah.
As you already said, I will start answering. As I already said, it was kind of a pleasure working with that corpus because things were very clear, things were presented in the right way, let's say. So I wanted to congratulate you guys about this work.
Thank you.
And then the challenges. So the challenges for us were in the kind of categorization of the errors. So at some point we needed to think how we will correct the errors and what type of errors are we correcting. So we needed to go into the corpus and try to get some statistics about what is there, what is not. And I think if there is a more, if there were some categories or some categorization done on the corpus before going to correcting the errors, it would have been not easier, but it would have helped, at least as another feature, or creating different modules to correct whatever.
But would you expect such categorization, if it existed, to also be made available?
Yes.
But for the test set, you don't have any information, obviously. So you have to predict those categories too.
Kind of, but
Okay.
if it is in the training or the dev set,
You could learn it.
rely on that
Okay.
to annotate whatever for done for the test, or to build some system to do it, and help the error for the
Okay.
categorization and for the error correction. So that's my one of
Okay. Okay. I mean, the directness was very, it was small, in fact, in the data, as far as, I mean, there was lots of data that was excluded that was highly dialectal, and I think that was kind of limited. Yeah, among the errors, yes. Okay.
When we added this component to the existing module, we didn't achieve any improvement.
Okay.
Because they are not consistent with the training data.
A lot of aspects was really nice how the basic idea sort of we neglect the punctuation error, we can aim for 0.7 as So we didn't really work on the punctuation. We have added some kind of small plugin at the end to find the get some error related to punctuation. Second one, I guess the meta was we had a detailed understanding the corrections. Sometimes you can find a fracture corrected to be a fracture with added
Yes.
on the top and the on the bottom. So we need to take actions at the end. So
Yeah.
America could be America or America.
Yes.
It's not completely.
Yeah, I mean, there's some cases, of course, where, you know, like the famous case, Hispania and España are both acceptable, in fact, and of course they have two other forms depending if you write with a ta marbuta or an alif. Yes. The back, yes. No, I mean, this was something we struggled with definitely when we were doing the annotation. It's possible some of these come from the earlier period of doing the annotation. I think, I mean, Wajdi can correct me here, we ended up actually taking the standard that's used by Al Jazeera for their internal, like, consistency check. So maybe what we have to do is go back to the earlier period, see if we actually followed this, and maybe re-annotate some data. Yeah. Thank you.
The second release of the data have modified some standards that from the first release.
Oh, really? Okay. Well, I mean, please, I mean, if you can send us more information on this, we'll make sure to fix it. Taha?
Especially when we have dialectal words, also problems with words with many errors in the text, and the main word we have a problem with is n.
Yes, and yeah. Yes. Yeah, the inna problem is an interesting problem. There's been actually work on doing diacritization of this that's quite old that's been done. Yeah, I agree, and I bet you actually the annotators are not agreeing completely either. I mean, some issues there. You want to say, if you want to, we were talking about the challenges or surprises, or they told everything.
Words that can be the American Spanish.
Okay. Yeah. So cases with multiple results, multiple answers.
Yeah. I think our main problem was the lack of time. So it's really hard to build a system for a company because
Yeah.
our university.
We have so much time. I'm so bored. You know, just I'm just like, we have so much time. Yeah. We think we do, but we don't.
The main problem is we lack of time, and as I said, the punctuation recovering.
Yeah.
And it was hard to understand how the punctuation was corrected by the annotators.
Right.
But surprisingly, the statistical SMT system was able to understand how the annotator did the correction. So we were surprised that the results were not so bad for the work that we did.
Yeah. I mean, one of the things that's kind of interesting is that when we take some components, as Ella presented, out, like when you ignore the punctuation, you know, the system in Columbia did not do as well as the system from Cairo University, which then became actually the better performer. You know, so it would be interesting to do a system combination at that level. Like, so we could, for example, in our group, Rami Skandar was the one who, over there, was the one who did the punctuation insertion component. He did nothing but punctuation, you know, whereas other people worked on other phenomena. And it's possible that, like, we can make that component available to other people or run it on other people's data and see, you know, how would it work if you had Rami in your team? You know, you get the Rami factor in, you know, how would that do? Yeah. So I'm hoping one thing that could come out of this is actually potentially people collaborating with each other, you know, and like playing with sharing pieces, possibly. Okay. I mean, in terms of second set of questions that I had was in terms of the kind of the organization of the shared task. I mean, you all said very kind words, you know, supporting us, but that doesn't help us improving. So what were the things that we did not do well, or things that you would wish we did differently or better? So think criticism, you know, that could include, for example, general organization, timing, selection of the data, size of data, metrics that we used, any other ideas or suggestions? Go ahead, yeah.
Okay, one thing that is usually done in evaluation campaigns is to have a task that is constrained regarding the data that you are using for building your system, and it helps to have a better comparison between approaches and algorithm. Here we can use any data. I used 500 million words for the 1 individual data, and I saw that there is a difference in the improvement with the same system. So I think next year, if you can have a task or
like a condition that's
with constrained training data.
That's something we actually discussed in the group of having like a constrained set where we would have to then provide, say, you know, you can only use GigaWord, or you can only use this data set. And we were afraid that if we do this, that some people would just not want to participate. Because, you know, like I would imagine that someone who's developed a system, let's say, independently, using all kind of resources, or in a company that have their own magical, you know, powers, they don't want to necessarily have to share, you know, they want to use them. And if we just say you cannot do it, it would not be advantageous. But maybe next year we can say it's another condition, you can participate or not.
Yeah, but usually it's two conditions.
Yes.
So it's the constraint condition,
Right.
the restricted training data, and there is the
And condition, yeah.
condition. So if you want to use your other data, you can apply to the unconstrained condition.
Excellent.
So it's not
Yeah.
forcing people to
Yeah.
use only a small set of data.
Right.
They have gigabytes of Arabic text.
Yes, I agree.
Here we evaluate also only the accuracy of the systems. What about the speed of the system?
Okay.
In real life, users need the system to be as fast as possible.
Okay. Right. Of course, doing this evaluation fairly it would be a bit more complicated, right? Because you would have to measure the speed all on the same exact framework and otherwise we would have to just do self-reporting, right? And in which case, you know, who knows? I think, you know, maybe we can find some way of doing this, but it's not clear, yeah, how, yeah.
In this case, it's not going to be fair to evaluate the speed because it depends on the resources used.
Yeah.
If you're using GigaWord or the error complex list, you know, to access it and get information from it, that like, or to use it, it's not something.
If you have, you know, 1,000 core machines, you know.
You need, like, it depends on the machine. It depends on the resources you have in your lab. So I don't think it should be the main criteria for evaluating.
Yeah. I think I agree with you only from the point that it's actually hard to constrain enough. It's going back to the constraining issue again. But if you can think of a clever way of somehow asking the question, that would be interesting. Anything else we didn't do well?
I had a comment about,
please.
The submission of the system and time, actually.
Mm-hmm.
You know, the shared task is correlated with the Arabic NFT workshop. For some people like us, we submitted, for example, a paper in the main workshop and a paper in the shared task, and we were kind of obliged to submit the things in the same time, and it was kind of, a race. I think you should think of the deadlines, and all of these things to make them a little bit separate, that people can participate easily involved.
Okay. Fair enough. I mean, I think one of the constraints that maybe we didn't think carefully is that we wanted people to submit papers describing their system, and I guess we could have negotiated with EMLP, like the publication chair, to say we'll have like another deadline that's much later, and we'll do fast review so long we get everything in time. So maybe I would expect that you would want to do the submission for the workshop first, and then do this, and then submit your paper. Okay. I mean, that's actually a good feedback. We can do that, yes. If I may ask of the people who are in the audience, I mean, who knew about this but chose not to participate, or considered participating but decided not to, why, if there is any such thing? Okay. So maybe we should have announced it a lot earlier and wider. Yeah. Okay. That's very good. So now you know you're ahead a whole year. We were doing it next year. It's 1 year ahead of time. Please participate. Okay. So the plan is the core data that's currently available will be the same modulo any issues that, like the ones Michael was talking about, we'll have to fix them. But the data will pretty much be the same. We will add some data. It's not going to be a lot more. It's probably going to be closer to 200, 300,000 words in the training that will include non-native text. So the majority will still be Al Jazeera. We've kept about, I think, 5 data sets that are test sets to have 5 future campaigns, basically using this data from the money that we have from the Qatar Foundation to do this project. So hopefully for another 5 years we can do this, unless we get other resources to annotate more data. Yeah, so you'll get additional data that is non-native that could help you adapt, perhaps. It's going to be an interesting, different task. There'll be separate tracks, one for natives and then one for non-natives, and maybe 2 tracks, constrained and unconstrained. I think that's something we were interested in doing. So there's options to participate there. Okay. So let me go to the last kind of set of questions that I thought of asking about the challenge, this spelling correction. So one thing about the numbers that we use, and just to kind of contextualize this, when we say you're getting 70% F score, this is not saying that the text is 70% correct. It just says that of the errors, which are about 30% of the data, you are able to get F score of 70%. And I actually find this always kind of a little bit counterintuitive. I want to know what the accuracy is. Like, what is the correctness of this text overall? How can I trust it? So perhaps that's something that could be added. But independent of that, we still have a large number of errors that are not handled, even if you ignore the punctuation question. So wanted to just ask your impressions about what do you think are kind of the main problems with this particular kind of task? I mean, spelling correction, something seems easy, a lot of things seem hard. Why? What do you think? If you could think, let's say 5 years from now, where do you think we could actually be in terms of, addressing this problem, solving it? Would we be able to have something really high accuracy and very fast to bring up the question of speed? How far are we from solving the problem? I guess that's the short version of it. Michael.
My counter is there is no correct answer. For example, you can find some Colombian phrases or maybe half sentence or complete sentence, and they are not corrected, so maybe they are accepted.
Mhm.
You can find these thoughts in the data and writing the correct answer in classical Arabic or MSA, so won't be the same. So some colloquial are corrected and some are neglected due to the construction.
Yeah, actually, maybe I should clarify something about this, the colloquial effect. So, we, in the guidelines, which Wesdi was responsible for organizing with the group, we made a decision early on to avoid making changes to the lexical choice that people write. So, if somebody, used, تطلع or some other, راح أبي إلى السوق, or somebody was talking about that earlier instead of ذهب because it doesn't sound as good. We decided not to actually make those changes. So some things, may look like they are dialectal or, let's say, less formal but we still consider them to be standard Arabic. And I'm sure there'll be cases where the annotator did not do their job. I mean, this happens in a small percentage of the time. But this was really hard because the moment you open it up to style changes, every one of our annotators had a different opinion. Some of them came from different countries with different educational backgrounds, and they were just making it was very hard to get them to agree. And it kind of made me think, because I'm a machine translation person, kind of primarily, this is really like a machine translation problem. There's multiple answers, and maybe one way of dealing with this could be to add multiple solutions, multiple results that to try to match against. Now, we don't actually have money in Qalb to do this. This was just not going to happen. 2 million is already large. But one idea, I wanted to kind of get your opinion on this, would be, would you think, in the future, like this is done in the workshop for machine translation, to say, all the participants commit to spend a bit of time recorrecting or looking at stuff that's been corrected supposedly in the test set and changing the gold. Let's say to say, I actually think my answer is better. I actually prefer this, or maybe evaluate other people's answers. But if we do this, would that make some of you not want to participate, even though it may make your systems look better? So it's kind of, what do you think? You would not participate? You have students, just get some students at Cairo University to do this. You're not going to do it yourself. I see. Okay. All right. Fair enough.
So it's a kind of adjudication phase that you're proposing?
Yeah. I mean, it's kind of like the human translation error rate kind of idea where you look at the output from the machines and you just say, something, this is actually fine. I accept it as is. Or, I actually, there's one thing I want to correct more and make it closer to the gold, or you think the gold is actually not correct in this case.
But which output would you select? Make a bias.
Yes.
By selecting one output. If you select the best output, for instance.
No. Yeah, you cannot do that. Yes. Yeah, so I mean, you would have to actually take a smaller sample from everybody in that case and reevaluate, which is hard. Yeah.
You said how perfect the systems will be, right?
Yeah.
For our system, for example, give us more data. We get better results.
Yes. Yeah, that's the easy answer. Give us more data. Yeah. And then you just do lookup at the end, right? Yeah. So, one of the things that I really liked the analysis that Ella did was this the Oracle analysis to look at the system combination. Would you be interested in pursuing this in collaboration with other people? Do you think this is something worth doing? Yeah.
We already started with Ella.
Oh, very good. Okay.
Combine our systems.
Okay.
So the others are interested in.
Okay. So now may finish with one last question, kind of in anticipation of next year, because there will be the twist of the non-native data, right? do you have any sense, without having looked at any of this data? I mean, Allah is probably, and me, are the only people who have seen it because we're in the team creating the data. But do you think, what were some of the challenges that you expect? And maybe in thinking about this, what should we do as part of setting up the shared task to avoid mishaps or things that, we should have thought about this more carefully? So non-native data is data written by non-Arabic speakers who have learned Arabic. Many of them have learned it in universities. So they're educated and they're writing essays. So it's not like tweets written by non-native Arabic speakers.
I think that the task could be more difficult
because
I can imagine that in maybe one sentence we're going to have more than one error to correct. There are going to be a lot of errors, different kinds of errors in the same sentence. I think that, I don't know if we're going to have to have another identification, or you guys will prepare this and give us the data. It depends on your choice. And I think it's going to be more difficult than this one.
Yeah, we expect it to. Okay. Has anybody worked actually even here like on the question of error correction for non-native? I mean, Ella, of course, you may not know this, but Ella was the winner of the Connell in both years. So that's why she kind of grabbed her to be. So this is the English as a non-native language. But, you know, has anybody looked at data in Arabic with non-native source? No?
We had a master in Cairo University computer and information.
Okay.
About errors and how to correct them for non-native.
Do you have the name, or can I email you to get the information? That's great, thanks. Yeah, go ahead, and then Samah.
I'm just talking about, like, I don't Arabic as a non-native language for so many years. And I disagree with you when it goes that advanced students in Arabic, especially in the USA, and if you go to the University of Texas, Austin, and ask for their writing composition. And now I'm teaching native speakers, and you will find that the mistakes either will be similar or even with the non-native be less.
Okay, is it similar to what? Similar. I see. But I mean, when you talk advanced, that's another story, I suppose. But I mean, for beginners, you would obviously you would expect the errors to be different. No. I mean, come on. There is learning the alphabet, and then there is being an advanced professional translator. I mean, that's a very large. Yeah. Yeah, maybe like level 1 or level 2, for example. I mean, I would expect that there would be agreement errors. I see. Okay. Interesting. Oh, okay. Go ahead, Mahsen.
Mixing the errors may not be practical. I mean, some people, journalists, also writing, this is a separate story from someone as non-native Arabic speaker. I mean, to mix the data.
Oh yeah, we're not going to mix the test sets. Will be 2 separate test sets. So you will know ahead of time. Yeah, you will absolutely. Yeah, we agree completely. I mean, there is actually a paper on identifying whether the source, the nativity of the writer, for example. But that's not what we're talking about. We will actually give you 2 test sets, one that is native, one is non-native, and you can use 2 separate systems. And in principle, you can choose to only participate in the native or only participate in the non-native or both or neither. Samah.
In the library of Alexandria, we have a very big project called the 1 million book project, where they can participate with different organizations or the world to digitize 1 million books.
Okay.
And part of these books are in Arabic.
Okay.
And if you log into dar, DAR, .bibalex.org, you will have something like 130,000 books digitized.
Okay.
And I think that many of them are non-native speakers, writers. So if you think that some of this data is good to you, then you can contact me.
Sorry, these are Arabic books written by non-native speakers?
Some of them.
Okay, some of them, I see. But we don't know which some.
Because I see that the author is not a native speaker of Arabic.
Other translations?
Other than translations, yes.
Okay, okay.
So I will find out for you.
Please, I mean, if there is any data that we can use.
Written by those
Okay.
writers, then I think I can.
When you say digitized, is it scanned or OCR?
Scanned and OCR.
Yeah, which brings.
Corrected or not corrected?
Yes.
Oh, it's manually corrected?
Yes.
Really? Okay, well, that's interesting data for other.
For this purpose, the problem is always with the copyright.
Yes, yes.
But we are dealing with this issue these days in order
see.
to fix the problems of copyright.
Okay.
Because this would create a different test set.
Yeah.
You know, OCR, which is corrected, which would be the gold standard to the OCR errors.
Right.
So you could use this like, okay, machine translation has errors, non-native speakers have errors, OCR has errors, so it could be different. And especially on historic documents, I think the libraries would be very interested in going the OCR.
Yeah, there is actually, I mean, there is a nice data collection at the LDC for OCR data, which actually was created in reverse. So it was text, newswire text that they gave people to write by hand. So they had the gold and then generated the handwriting and then did the OCR and got, you know, the results to go with it. And that data was really hard to improve. Yeah, that's true. That's a very good point.
It's always improving. And
Yeah.
I think if it was not that good, now it's improving. In any case, you can have some source of text in order to start with. Maybe you can go with it.
If you are willing to donate a test set to the Qalb project, we would love it. And we could also have our annotators go over it. So something around 50,000 words would be great. Think about it, yeah.
I think this would be like OCR error.
Yeah.
Non-native.
Yeah. Yeah, it's a different. No. It would be like post-editing OCR, like post-editing MT, post-editing. That's right. Yeah, it's machine Arabic. Yes. Violetta.
On the non-native task, I'm thinking about a particular population of non-native, quote-unquote, non-native speakers. In Morocco, we have a number of students who go to French language schools, and then they arrive at our university and they have to take a certain number of Arabic courses. So they are native dialect speakers with a French training who learn to write in formal Arabic.
Right.
Yeah. and I'm wondering if that's a data set that might be interest to do it if I can get it.
Absolutely, yeah. The more interesting variables and conditions, that, you know, I mean, I think it would be interesting for sure.
I also have suggestions concerning this, because many of my colleagues are working, not native colleagues, I mean, they are not Arabs. They are, for example, from the International Islamic University.
Okay.
And they are Malaysian people writing in Arabic.
Yeah.
I can contact them, and this is for sure. Their publications, books, are non-native. The books are non-native.
Yeah.
And then I think they can give us such set of
But the
data.
problem of books is that before publishing the book, it is edited.
Yes. Yeah.
So we will not find errors.
In principle.
Unless you get what they are writing before giving to our editor, we can find errors.
Because I can help in this because my uncle is working there. He's a professor of Arabic.
Okay.
And his colleagues.
I know someone who knows someone.
Okay.
Yeah. Okay.
His colleagues giving him
Yeah.
the publication to revise.
I see. Oh.
Then we can have these sources.
Yes. Here's the previous and the revision.
And the source.
That would be great. One last question from the lady here.
No, it's just a comment. In addition to the point of really defining nativeness, do you think that the general purpose is, or the ultimate goal is to develop a general purpose spelling correction system? Would it be more beneficial to jointly train on different kinds of data sets and sort of separating the two tasks?
Yeah, so we're actually, that's a very good question, and the answer may be empirical, I think. I mean, we don't know what is the best way to train. We are not suggesting, in the evaluation, when we separate, we're only separating the test, right? So this is kind of the question that Mahsen asked. The test will be marked as, you'll get a hint basically. It says this test came from native, this test came from non-native. You are welcome to build a system using all the data together, add additional data, create your own data, contact Samah's uncle, get his data. I mean, it's really completely up to you. I think it will be really interesting, I mean, as a field for us to figure out what is really the magical combination that will work best. Would it be, to use all the correct native and then apply it to the non-native? Is the non-native, do we need to hit more non-native data, for example? I don't really know. And the right combination, I don't have an answer on. But we don't have any restriction. I don't presume anything.
That's exactly my point. What is really the ultimate goal of the task? Is it to develop a general purpose?
All right. So the ultimate goal, there really isn't one ultimate goal. I mean, in some context, you can imagine, a company, like we have a couple of companies on the panel, who are interested in developing a general purpose, I suppose, or a spelling checker that works specifically for non-natives to help them get educated. I think these are all good little ultimate goals of their own. For the technologists who are interested, let's say, in doing machine translation or building better language models, they may just want to run this on all of their data to make cleaner data to build better models. And they're not as worried about mistakes happening, some percent of the time. And these are also good goals. So I think the general goal is to improve the quality of the text in some way that is consistent, that is independently defined, following, standard grammar rules of standard Arabic, modulo, America, España, etc. Cases that have two answers. And then you work with it. I mean, there are different people can use this for different reasons. And we're happy to make all of that happen. Okay, I think, thank you everybody. Now, there is, sorry, you can't run yet. Lunch doesn't start yet for another 10, 15 minutes. So thanks the panelists. So before the poster session will be during the lunch. So please grab your lunch, come back, and talk to different people. We asked also the poster presenters from the main workshop, not the share task, to also present 1 minute or so presentation to kind of attract you to come to their posters. So they will do this now. So. Very good.
Okay. So I invite the first presentation. So for the poster, which is the framework for classification and annotation of multi-word expression in dialectal Arabic. So this is supposed to be by Abdullati Hawari, but I'm not sure. Is it Heba? Yeah, sure. I invite you. Thank you. Yeah.
Hi everyone, so I have two posters. The first one is about multi-word expressions in Arabic. So there is no unified way for defining multi-word expressions, and there is no universal way for the taxonomy. So what we did is that we provided a set of guidelines to do annotation of multi-word expressions on different levels of linguistic representation. So we have an 11-dimensional framework. If you're interested to learn more about it, you're welcome to my poster, which is not mine actually. Yes.
So
Next one.
the second one. So this one, I think this.
No.
So,
I think
so the second one is Al-Bayan.
No. The third, no. Named entities.
Okay, so named entities. Which one? So this one?
Yes.
Okay, so number 5. Okay. Okay, please.
And the final poster, promise no more posters by me, is about named entity recognition in dialectal Arabic by my colleague Aya Zirakli. So I'll skip over the challenges in Arabic since you probably all know it. And so this is the system I'm presenting. Like, it uses a set of rules, a set of features like morphological, lexical, contextual, as well as a set of gazetteers and Brown cluster IDs to perform named entity recognition in Egyptian Arabic. But which features give the best results? Are they morphological, Brown cluster IDs, gazetteers? Again, come to the poster if you're interested to know more. Thank you.
Thank you, Eva. So our third presentation will be so this one. So I invite Hiba Abdel Nasser. Okay, you're not. Okay, so it's Al-Bayan, an Arabic question answering system for the Holy Quran.
So my name is Noha Yusri. I'm just a representative for the authors of this work, Al-Bayan. It's actually an Arabic question answering system, and it mainly depends on the idea of like how accurately we can answer questions about Quran, and it integrates ontology, Quranic ontology from 2 corpuses. And also depends on some named entity recognition corpus from Quranic corpus. And then the main accuracy depends on the part where the question answering is. And welcome to our poster, or their poster, sorry.
Thank you. So the next one is in PowerPoint actually. So let's. So I invite automatic Arabic diacritics restoration based on deep nets. Ahmed Al-Salah. Sorry. Okay, so it's yours because it's PowerPoint actually. Yeah. So this one.
Thank you. Assalamu alaikum. My name is Ahmed Saleb from Cairo University. I'm presenting here a proposal for Arabic. Oh, there is animation. Proposed system for Arabic diacritization based on deep nets. Actually, this is part of larger research. It was conducted between 2010 and until now on deep neural nets, and we applied it as a part of a bigger framework based on deep neural nets where the basic classifier is a DNN, and also the feature extraction networks for extracting features like part of speech tag, morphological lexemes are trained specifically for by DNNs. We consider the context of the characters as well as the context of the words. Also, we consider the context of the input features and of the class diacritics labels. This helps in the syntactic or the case-ending diacritization problem. Then we propose a network of networks architecture where a special DNN is trained to resolve the confusions between some target classes we found to be highly confused from the training set, like Kasra and Kasratain and some other targets. And by collaborating in a bigger network, we refine the decision at each level, and we fuse the decisions all together in a DNN to get a better accuracy. Here we we present here the contribution of each improvement we propose to the overall accuracy. So we find here that using the context features improves the overall accuracy by 4.35%, Using feature like the last character identity have a good impact on the case ending decretization accuracy by around 4%. And using the new method of confused subset resolution improves by 2%. And finally, using the context of class labels and characters each improves by 1.1%. The baseline we were comparing to was at 88.2%, and our accuracy finally reached 90.2%, so presenting 2% improvement. And you are welcome to ask me any questions at the poster if you want. Thank you.
Thank you. So our next poster is combining strategies for tagging and parsing Arabic. I invite Alan Ramsey. So yours is it's number 4. Yeah, it's this one. Please.
Okay, this is joint work with Maitham Al-Abbas, who couldn't be here today. We were in a situation where we had 3 taggers and they were all reasonable, and we thought maybe we can do better if we find a way of combining them, and we used a method for combining them which has been used in computer vision, but I haven't seen it for this task before. And it worked quite well, so we wondered whether we could use that for combining different parsers, and we used 3 well-known parsers, and these were the original scores, and those are the final scores that we got after doing the combination. So combining Mada and Amira and our own tagger, we got 99.5% accuracy on a coarse grain tag set and 96% on the fully fine-grained PATB tags. And on combining the various parsers, we also got a fairly substantial increase. Annoyingly, the clever one that we invented for doing this didn't work at all well for parsing, and we had to back off to a less interesting one, and I'll tell you about the various ways we did it if you come to the poster.
Thank you. So our next is semantic query expansion for Arabic information retrieval. So it's just to make sure. This one? Yeah, okay.
No, this one.
This is number 6.
Yes, this
okay.
one.
Yeah.
Hello, I'm Mohammed Zahran. What we're doing here that when people tend to search for something, they have a specific idea in mind, and they use certain words to express this idea to search. Our job here is to try to fill the gap between what people mean and what they write. So we're doing some expansion to the queries people write in terms of four pillars. The first one is to handle the sub-concepts. People, when search for words like violence, العنف, they want pages that has subcategories of this idea, like extermination, kill, and whatever. We handle also similar concept. When search for a word like England or Egypt, we can have some similar words that represent the same entity. We also handle synonyms when we can expand words by synonym like door or role, part or in. How we do it, you are welcome to see it in our poster. Thanks. Thank you.
So our next is transliteration of Arabizi into Arabic orthography, developing a parallel annotated Arabizi Arabic script SMS chat corpus. So this is number 7. Okay, please.
Okay, thanks. So this is actually work by the LDC, which I helped them with a little bit. What it is the LDC, as part of the BOLD project this last couple of years, developed a parallel corpus of Arabizi with Arabic script. It's 300,000 words. So this is Romanized Arabic and being mapped to standard Arabic. And if you come to the poster, we'll tell you about how we did it.
So our last poster is Tunisian dialect WordNet creation and enrichment using web resources and other WordNets. Okay. Please. Thank you.
Hello, I'm Ayman Khlifi from Paris Sorbonne University. Our work presented in this poster is about the building of a new lexicon resource for the language, for dialect language spoken in Tunisia, to build this, to build work, to build WordNet for Tunisian dialect. We process by firstly keeping all standard Arabic WordNet and English WordNet in the same database. Then we create a large corpus from open data, mainly from Facebook commands, Twitter, TripAdvisor commands, and other open sources. Then we cluster, then we extract only Tunisian dialect word, and we apply Kamod algorithm to group similar words. Then we proposed the resulting then we propose for a native speaker expert the resulting cluster, and his role is to add a relationship between the new word and the existing scene set. We added some new feature compared to standard WordNet, like SMS script language, the origin of the word, and the frequency of use of each word. Thank you.
So I would like to thank you, everyone, for these presentations, and I invite everyone to have a look at these posters and also for lunch. So it will be a mix.